Hello friends, from this video we will discuss how to convert an NFA to DFA, because many times in the question it is given to construct a DFA, but sometimes it is hard to directly construct a DFA. We will see several examples further. So we know that it is easier to construct an NFA. So we can first convert the given language into NFA, and from the NFA, by the method that I will discuss, you can convert it into DFA. Basically there are two methods for the conversion of NFA to DFA. Here I will not discuss the conversion of epsilon NFA to DFA. I will discuss it in the later part. But the one method that is used to convert is called set subset method, and otherwise you can directly by practice convert it by observing. We will discuss both methods one by one. So let us see the first one and the rules for the conversion of this. So the first one is self subset method, and the rules are: first, when an NFA is given, we need to draw or construct a state transition table according to the given NFA. For example, even if any language is given, then we need to draw NFA, and according to the NFA we need to construct a state transition table. A state transition table we had already discussed, and we will see for further examples. The next rule is that by observing NFA transition table, construct a DFA transition table, and the steps for this are: we need to take the initial state of NFA as the initial state of DFA. The final state for all the final state which are in NFA, for DFA, all the state of DFA where any of the final state exists in DFA transition table. That means, for example, in NFA, if final state is A, and in DFA there are several states like A, B, a combination of A, B, C, then in such cases we will take final state as here A, AB and ABC, because A is existing in these things. And if there is no transition in NFA, because it is not necessary to show transition for all the states in NFA, we have discussed it already, so we have to take it as a dead state in the case of a DFA. And the third step for the set subset method is to, using DFA transition table, we need to draw our DFA, and it is a very simpler part. So let us discuss by one example. Okay, the problem is here: all string is starting with A. We already know the construction of NFA as well as DFA, but we will discuss it to make our concepts. So the first rule that I discuss, or the first step that I discuss, is to construct a state transition table according to the given NFA. So first we need to construct the NFA. The NFA will be like that: starting from the state A, we need to start, so A should be starting, and after that whatever will come we will accept all these strings. So this is the NFA for this question. Now we need to construct for the construction of state transition table for NFA. So we will write the states in this, and the states here are A and B, and the alphabets here are, as we can see, that A and B. So we will write here A and B. Now we have to show the transition. So for the state A, if we have small a as the alphabet, then B reaches to state B, and for a small a on transition of B there is no transition. That means here we can write phi, and this phi we will take as a dead state in the DFA that we have discussed here. This part, for no transition in NFA, consider it as a dead state in that case of DFA. Okay. For the transition of B, if A comes, B reaches to state remain on state B, and for also B remain on state B. So this is the state transition table for the NFA. Now the state transition table for our DFA. So again we will write what we discussed. We discussed that we will take initial state of NFA as the initial state of DFA. Okay. So initial state of NFA will be the initial state of DFA, and the alphabets will be remain same for both NFA and DFA. Now for A on transition of small a, we can see that here in the transition table in NFA we have B. No problem, we can write directly. Again from state A on transition of B reaches to state here phi, and this phi will be the dead state in the NFA. So we write this as dead state D. Again now B doesn't need to take all the states from NFA. We will observe the state transition table of DFA. Here we have taken all the transition for state A. Now we will consider all the transition for the state B. So we will write B here. Now if we observe transition for state B in the state transition table of NFA, we will find that here we have two transitions. B on transition of small a, B reaches to a small state B, and B on transition of small b, we will remain on state B. So we have already constructed the transition table of B, B, B. Now we need to construct the transition for D. But this D is, we already know this is a dead state, and for dead state, for all the transition we remain on that dead state. So this is the state transition table for DFA. Now we need to construct the DFA itself. So for DFA we can see here that their initial state will be A, and the final state will be, according to our steps, we can see that final state of NFA, all the state of DFA where any of the final state exists in transition table. That means here, since B is the final state, here also B will be final state. No else where is B is present. So B will be our final state. Now there will be three states. Let us name A, B and D. Now we have to show transition. For transition we can see the transition table. Here for small a on A we will reach to state B, and on B we will go to state D. By seeing this transition table, we had already discussed how to construct DFA using the transition table, and we will make, and here this our B state B will be our final state. So this is the required DFA. We already know to construct for this question, but when the question will be long or complex problem will be there, so this set subset method will be very useful. And we will discuss how to construct it directly in the next videos. Thank you for watching.